In a world that is increasingly demanding sustainability, non-ferrous metal recycling has become a very important practice. Opting for recycling does not only mean being responsible for the environment and reducing the carbon footprint, it is also a very reasonable business in industries that rely on using non-renewable resources. Fortunately, non-ferrous metals, especially nickel, silver, copper, aluminum, and tin, all share the property of being able to undergo an unlimited number of instances of recycling without losing any of their original properties. Recycling is also an economically sound decision, as using already extracted materials, even for metals such as aluminum, which is pretty much omnipresent, is cheaper than mining all over again. In fact, the numbers show that in some cases, it is even possible to save up to 95% of energy costs if recycling is chosen as the primary production method for aluminum. However, recycling non-ferrous metals can be a problematic task, as they will not always come in their pure form. Oftentimes, they are found in all sorts of liquid and solid mixtures from which they need to be extracted and purified before further use. Three methods used today for non-ferrous metal recycling are electrowinning, precipitation, and non-ferrous sensors. Electrowinning, which is also known as electroextraction, is, on the surface of it at least, a relatively simple process of extracting dissolved metals from their dissolved states using electricity. In the case of non-ferrous metal extraction for the purpose of recycling, the process generally goes as follows. First, the material, which can be any form of waste such as solid material from landfills or different types of solid mixtures containing non-ferrous metals, is put into a liquid solution where it is dissolved into a liquid state through the process known as leaching. The end result of this process is called a leachate or leach solution. Then, using an anode and cathode, an electric current is passed through the leach solution that causes the metals to be chemically reduced, resulting in them forming a thin, even layer across the surface of the submerged cathode. This way, the non-ferrous metals, such as copper, tin, nickel, or silver, are recovered and made readily available for further reuse. The second processing method for non-ferrous metals is precipitation. It is also the most widely used method for metal recovery from aqueous solutions. Precipitation can also be used for wastewater treatment, a process in which metals are recovered from aqueous waste solutions. This method includes two metal removal submethods called coprecipitation and adsorption. Not to go into too much technical detail, we will mainly address the basic method of precipitation without going too much into other aspects. Precipitation is the process of forming an insoluble solid material from what originally was an aqueous solution, typically involving pH adjustment for the addition of another chemical species. The end result is called the precipitate, while the chemical that causes this is called the precipitant. The most commonly used precipitants are sodium and calcium hydroxides or oxides, which are used to increase the pH, resulting in insoluble metal hydroxides. Finally, non-ferrous metal sensors are becoming widely used in sorting and extracting non-ferrous metals from scrap, most of which originated from end-of-life vehicles or from e-waste. For example, sensors are used for the detection and extraction of specific non-ferrous metals from zobra. According to the Institute for Scrap Recycling Industries in the United States, zobra is defined as a mixture of shredded non-ferrous scrap metals, primarily consisting of aluminum, but also containing copper, lead, brass, zinc, tin, nickel, and copper in any of their forms. Given the fact that we have already seen that used recycling aluminum can result in big savings, and the demand for other non-ferrous metals found in zobra, the commercial potential of this mixture, as well as the economic significance of extracting and sorting out these elements from the mixture, becomes rather obvious. Typically, these metals would be sorted either manually or by using sink float gravimetric treatments. However, both methods are largely unreliable, as the first method relies on human intervention and observation, while the second method relies on the density of said materials. The problem arises because some of the non-ferrous materials are of similar densities, so they will not be separated from each other using gravimetric techniques. Using sensors, including for example X-ray transmission technology, which can target different materials based on their atomic density, is significantly more reliable and almost completely removes arbitrariness, enabling the enhanced separation of the scrap metals acquired. For example, in the case of finely cut copper-containing wires, which are often accompanied by traces of brass or stainless steel, usage of sensor-based technology makes it possible to detect and remove copper particles smaller than 1 millimeter in size from the mixture, ensuring purity of greater than 99%, a rate that could never be matched by most sophisticated sink float mechanisms or the most scrutinizing eyes. To sum up, some commonly used methods for metal recycling and recovering non-ferrous metals are sensor-based methods that rely on the use of sensors to detect and sort specific metals, precipitation methods mainly used for recovery from aqueous solutions, and electrowinning that has broad applications across many different industries. It is important to note that all three of these methods are complex and that describing them in greater detail and tackling some more technical aspects exceeds the scope of this video. Hopefully, today you learned a thing or two about the methods of non-ferrous metal recycling. Please don't forget to subscribe for more videos like this.